All right, welcome to my first ed puzzle, looking at Chapter 1 of Chemistry, Matter, and Change, specifically the section Chemistry is a Physical Science. So you may want to grab your Chapter 1 active notes so you can follow along and fill in. You will be having a quiz on Section 1.1 tomorrow. Okay, so our learning objectives for this chapter are define chemistry, so be able to define chemistry, list examples of the branches of chemistry, there are 6 of them, and then compare and contrast basic research, applied research, and technological development. So chemistry studies matter and its processes. Specifically, it looks at composition. What exactly is the chemical that you're looking at made up of? So if I'm looking at sugar, I can, figure out that it's made up of 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Its structure. Glucose can be in a ringed shape. It can also be linear. Its properties, specifically like what state is it at, what color, what form does it take, what's the melting point, solubility in water, density, so on and so forth. And then finally, the processes and energy changes that it can be involved with. So sugar is made from the process of photosynthesis. You take water and CO2, a little bit of sunlight, and you make sugar. Sugar is also involved in cellular respiration, where it breaks down to produce carbon dioxide and water. So there are several chemistry branches and they can overlap. So here are the 6. Organic means that you're looking at any compound that contains the element carbon. Inorganic are your organometallic. Basically, you're looking at the study of non-organic substances. Some have organic fragments bonded to metals, so hence the word organometallics. We have physical chemistry, the study of properties and changes of matter in their relation to energy. We also have analytical chemistry, which is the identification of the components and the composition of materials. Biochemistry, the study of substances and processes occurring in living things. And then finally, theoretical, where you're going to use mathematics and computers to understand the principles behind observed chemical behavior and to design and predict the properties of new compounds. So let's take a look at what exactly is a chemical, right? So all of these branches work with chemicals, and the definition of a chemical is any substance that has a definite composition. Okay, so examples of chemicals: sucrose, water, carbon dioxide. Okay, the fact is they're always made of the same stuff no matter where the chemical comes from. So here's some examples of chemicals: nitrogen gas, oxygen gas, CO2, methane, krypton, xenon. They can exist naturally or they can be manufactured or made. So here you can see this picture of a cloth fiber with selenium nanoclusters. But the point is, you depend on chemicals every day. I mean, you're always using chemicals. We drink water. You brush your teeth. The clothes you wear, cotton, that's a chemical. The air you breathe. This is a picture showing hydrochloric acid, an enzyme called pepsin, and then when you combine pepsin and hydrochloric acid. Now, all of these are found in your stomach. But if you just had a stomach that just only contained hydrochloric acid, you can see that it doesn't really do a nice job digesting that piece of chicken. Pepsin does a better job, but then when you put the two together, then you can really get some work done on that chicken and break it down so you can utilize those nutrients. Okay, moving on to the different types of research, the 3 types. So basic, applied, and technological. So you have to be able to know these 3. And if I were you, I would read the section in the book and read those examples, because on your quiz, I think I list examples or like situations, and you need to know which situation I'm describing. Okay, so basic research, the purpose of it is really it's carried out for the sake of increase in knowledge. Okay, they're looking at the how and why a specific reaction occurs, what the properties of a substance are, and I'm going to talk a little bit about the discovery of Teflon with this one. Applied research is generally carried out to solve a problem, maybe the development of new refrigerants. Okay, I think your book gives that example. And then finally, we have the technological development. Typically involves the production and use of products that improve our quality of life, like computers, catalytic converters in cars, or biodegradable materials. But all three of these often do overlap, as in the case of my Teflon story. So Teflon, the patent was issued back in 1941, okay? And Teflon is tetrafluoroethene, okay? And when you get a bunch of it together, then you get a polytetrafluoroethene. So it says Teflon is the brand name for the polytetrafluoroethene, PTFE. It's a white, waxy substance and was actually created by accident by Roy Plunkett in 1938. During research on new refrigerants, the tetrafluoroethene Plunkett was using was accidentally polymerized. So how does it work? Teflon's nonstick properties are in part due to the strength of its carbon-fluorine bonds, as you can see here, carbon and fluorine, which are chemically inert. Additionally, due to the fluorine atoms, the intermolecular forces between PTFE and other molecules are very weak, and that's why things do not stick to it, because the interaction between PTFE and those molecules, they're not strong enough. So, during appropriate use, Teflon does not reach the temperature required for it to degrade. However, if the coating is overheated, the polymer can begin breaking down and the fumes produced can cause flu-like symptoms. At present, the long-term effects of human exposure to these fumes are still largely unknown. So you can see the melting point here. And the recommended, maximum safe use of temperature. Now, we tend to use, obviously, Teflon in cooking. Okay, non-stick pans. But my husband and I have discovered another use for it. Okay, we didn't discover, but I'll tell you that story here soon. So anyways, how does Teflon fit into the three branches of research? Basic, it was discovered by accident. Applied, doesn't let food stick to the pans. And the technological development, well, it's not perfect. It can peel off, so we do need some improvement on that. So here are some ads for when Teflon first came out. We made it for ladies who want more than just slickness from their Teflon. Yeah, okay. Amazing new concept in cooking. Nothing sticks to Happy Pan. Yeah, no. Okay, anyways, my husband and I are slightly obsessed with Chernobyl. In fact, I think, like, within the future, if we were to ever travel overseas, we would probably go see Chernobyl, in Pripyat and all of in that area, really. But anyways, we were watching the Netflix video Chernobyl Megatomb, the building of it, and basically when Chernobyl, okay, so maybe I should just back up. So for those that don't know what Chernobyl was, Chernobyl was a nuclear accident that occurred back in April of 1986 in Pripyat, which is just north of in Pripyat, which is basically Ukraine, kind of Russia area. And it's probably considered the worst nuclear disaster in history, and was caused by one of only two nuclear energy accidents related at this. Fukushima is pretty close to it. So anyways, there was this huge accident where the reactor basically, I don't want to say exploded, but it just went off and released huge amounts of radioactive material. But anyways, they built I can't think of the word, like a sarcophagus in 1986 to kind of protect the radiation from escaping. However, it started to deteriorate, so they needed to come up with a new kind of confinement plan. So they built this huge mega tomb. and it took a couple of years, but they had to build it off-site because it's so highly radioactive, for people and for the machines and everything. So they had to build it off-site, and then they actually had to move it. Now, how they moved it, so maybe I should take a look at some of these stats here. So 1,200 workers on site, 2.15 million euros, involved 27 different nations, tons of screws. Construction began 2010, and I think they just finished 2017. So I mean, this took years. And then you can just see the length of it and the height of it, but they had to build it off-site. And how they were able to move it were these giant, like, oh, they're not cranes. Oh my gosh, I'm blanking on the, hydraulic pistons. Okay, so these are, yeah, these are hydraulic pistons. And see these pads down here? These pads are actually Teflon pads. So it was pushed on Teflon pads by these hydraulic pistons and basically guided by lasers, because you didn't want one side moving faster than the other side, because then it would add torque or tension onto the structure. So it's actually, a very unique process as to how they were able to move this structure. It took 2 days basically, but it's actually pretty cool. So anyways, Teflon not just used for cooking, but for moving a megatomb over Chernobyl. All right. So anyways, chemistry helps us understand our world by making better informed and more logical judgments. And then finally, that improvement of our lives. So, we use chemistry in pharmaceuticals, forensic science to catch the bad guys, right? And green energy. So, the assignment, I would strongly suggest reading chapter 1, which is found in your book, and then we will take a short quiz tomorrow on 1.1.